Okay, so once again, let's use our properties to solve this problem. So it says, first it says find the value of z. So if we look at our diagram down here, notice we have several angles labeled. This angle is at B is 4z plus 15, the angle at A is 2z minus 20, and the angle at C is 12 plus 3z. Now what was our property? What we have here, notice, is a four-sided figure. A quadrilateral is what that's called, and it's inscribed in the circle. Now our property was that when you have a quadrilateral inscribed in a circle, the opposite angles are supplementary. So what are our opposite angles? They're the angles across from one another. So A and C are supplementary. B and D are supplementary. What does supplementary mean? It means adds to equal 180. So again, in geometry, when you're solving for a value, it means you take a property we just learned and use it to set up an equation and solve. Our property was that we would try B and D, but notice D doesn't have a label with any of its values. So we're going to instead use A and C. They're opposite angles in this inscribed quadrilateral, so we know they must be supplementary. What does supplementary mean? It means that two things add to equal 180, two angles. So we know angle A plus angle C is 180. Let's replace angle A and angle C with what they're equal to. We come down here, angle A is 2z minus 20. I'm going to put a little slash on my z's so I can tell they're not 2's, plus angle C. Angle C says was 12 plus 3z. We add those together, and they should together be 180 because, again, they're supplementary. I'm going to combine my like terms. So I have my 2z and a 3z together gives me 5z, and negative 20 and a positive 12 leaves me with negative 8, and that equals 180. We want to solve this for z. We have minus 8, so to move that to the other side, we're going to add 8 to both sides. Okay, that gives me 5z equals 188. And now we are going to divide both sides by 5 to finish this up and get our solution for z. Okay, 188 divided by 5 is 37.6. So I've solved the first part of this. Z is 37.6. All right, next we're asked to find the measure of angle BAD. Now, when you're trying to locate an angle, remember the middle number in the letter, in the name, sorry, is where your angle is located. BAD is located here. What was it equal to? It was equal to 2z minus 20. We just found out that z is 37.6, so we have 2 times 37.6 minus 20. Go ahead and do your multiplication first. 2 times 37.6 is 75.2. We subtract 20 from that, and we get 55.2. Okay, next we are asked to find the measure of angle BCD. Again, look for that middle letter in the name. That will tell you where your angle is located. It's located at C. So this is the angle we're talking about. It was 12 plus 3z. So again, we know z is 37.6. We solved and found that. So we replace the z with a 37.6. We take 3 times 37.6 is 112.8. And we just add the 12. And there you have it. It is 124.8. Okay, let's move on to the next. Find the measure of angle ABC. So again, wherever that middle letter in the name, wherever that's where your angle is at. So our angle is at B, and the measure of angle B here was 4z plus 15. So again, just like we did with the others, we write down 4z plus 15, replace the z with what we found. It is 37.6, and just evaluate from there. We do multiplication first, so we do 4 times 37.6 gives us 150.4, add the 15, and we get 165.4. Okay, finally we find the measure of angle ADC. That's this angle right here. It was opposite angle B, and we just found that angle B is 165.4. We don't have any measures for angle D, but again we have that property that when you have a quadrilateral inscribed in a circle, the opposite angles are supplementary. So I know that whatever angle ADC is, when I add it to 165.4, together they should be 180 because again they're supplementary. Okay, that gives me that angle ADC. I would subtract 165.4 from 180, and it's only left 14.6 degrees for that angle. Okay, so again, with one property we were able to find the value of Z and then find the value of all of the angles in the figure.